S1 exam. This is the heat revision. First thing to understand the difference between heat, which is energy, and it's measured in joules. It's a J. That is different to temperature, which is a measure of how hot something is. And that's measured for us in either degrees centigrade or degrees Celsius, or if you're American, degrees Fahrenheit. They're still very old in what they do. There are three ways that heat can be transferred, passed along. In solids, it's called conduction. And this is, in effect, this idea. You've all seen one of these before, Newton's cradle. If I heat this particle up by giving it more energy, I lift it up, it will pass the energy on. And so that is what we're looking at with conduction. And that works only really in solids because the particles are close together. So it passes the movement on. And then in gases and liquids, we have what's called convection. Alright? And with this one, because the particles are vibrating more, as we've got there, but are not fastened, are not fixed, they take up more space. So their density goes down. So the hotter particles are vibrating more, so that's cold, that's hot. You can see it's taking up a lot more space. So hotter particles vibrate more. So they take up more space, so have a lower density. So therefore, as they've got a lower density, they rise. Think about in conduction. We'll come to radiation when I've got time to move the bottom. So think about in conduction. We've got particles vibrating like that. And if I make this particle vibrate more, i.e. it's hotter, it will pass the energy on, eventually reaching to the other side. Think about it in terms of, here is a steel rod, here's a flame being added, and here are drawing pins fastened by wax. As it gets hot, travels along, that will drop, then that one, then that one, then that one. When we're looking at convection, this time we've got the particles are wider apart. If I make that particle hotter, it's taking up a lot more room, so that particle will rise. Okay, as that rises, colder ones will come in to gain their fair share of the heat. This is why kettles heat at the bottom. The heat on a kettle will always be at the bottom of the kettle because the hot water they just made rises. Radiators always at the bottom of a room. except in B10, Mr. Lodge's room, where somebody put one just below the ceiling. Okay? These two methods of heat transfer need particles. No particles, no heat transfer. In a vacuum, you have no particles, so there can be no heat transfer by conduction or convection, but there can be by what's called radiation. Think about all the radiations that you know. If you've been hurt, you've been and had an X-ray, that's radiation. Everybody's got a mobile phone these days that uses radiation called microwaves. Yeah, radiation is just another method of this. And the main method that it uses, the main thing that's used for radiation, transferring heat, is infrared radiation. This is how we get our energy from the sun. And it gives it by infrared radiation, because there are no particles between us and the sun. Okay. This is why black things, black absorbs heat. One reason why people wear so much black in the winter is that they're going to feel warmer. The sunlight hits it, warms them up. Counter to that, obviously white reflects heat. And this, you can feel radiated heat if you put your hands around a cup of coffee. Some of the heat is going to be from the actual convection from the bottom of the cup of coffee. The majority of the heat, if you just half an inch away that you can be able to feel, will be radiated heat from the actual coffee, from the actual cup. We have on the board a fantastic drawing, as you can see, of a vacuum flask. Now the inside, the steel outer of a vacuum flask, or plastic outer of a vacuum flask, is made of glass. This is because glass is a poor conductor of heat. Okay? So it's going to reduce the amount of heat that gets lost. It's shiny on the outside, and that is to prevent heat getting in, because shiny surfaces reflect heat, reflect radiation. Right there. Right. It's shiny on the inside, same reason. Right. But this time it's to keep heat in. So it reflects the heat back inside into there. So it's capable of keeping things hot and keeping things cold, not at the same time. And then there's a vacuum layer in between the two glass, inside the glass. And this is to prevent both conduction and convection. No particles, so it's very difficult for any heat to be transferred by those two methods. The only way heat is going to get lost from this is that way. Okay? Just to finish off, good conductors, things like metals. Okay? Metals have a very nice tight structure. They can pass the heat on very well by conduction, so they're good conductors. Bad conductors called insulators are things like glass, air. That's why birds will plump up their feathers when it's cold, trap as much air underneath their feathers as possible. Plastics. And again, my fantastic artistic skills come into play when we talk about houses and how to reduce heat. So into the ceiling we put loft insulation. The idea being that this stuff is like wool and it traps air in between, so therefore it stops convection and the air can't move very far, and it helps prevent conduction. We have double glazing, sometimes triple these days, where we have 2 sheets of glass. Glass is very good at stopping conductivity, with a vacuum in between sometimes, or just an air gap, which again will slow down convection. We have cavity wall insulation. Between a house is built with an outer wall and an inner wall, and there's always an air gap in between. Again, designed to try and cut it, the convection down a lot. If you put some foam or some like peanut packing from packages, that will help even more. Carpets and curtains. Will also help to retain heat, and things like draft excluders. Will stop drafts getting in. Will therefore also help to keep the house warm. The last little thing on the heat topic, well, when we looked at infrared cameras. These will effectively take a photograph that is then overlaid on a computer screen, a computer image, all done inside it, to put different colours to different temperatures. So 37 degrees could be white, 35 degrees could be yellow, and you can get that change. You can see where hot spots are. Very useful. Police. Finding people who's done a runner. Yeah? Doctors. If we can see where there's blood getting to a place, more blood than usual, it will be warmer. So you could use that camera to highlight that ideas. Same with vets, often used on horses. Okay.